Good morning, class. Today we're going to learn how to solve two-step equations. Our standard is MA.7.AR.2.2. Write and solve two-step equations in one variable within a mathematical or real-world context where all terms are rational numbers. Our objective: the students will be able to interpret, write, and solve 5 two-step equations from word problems during independent practice at the end of class. We are first going to review solving one-step equations. The vocabulary we've been using in solving equations is equation, term, variable, isolate the term, addition property of equality, and subtraction property of equality. Reminder, our goal in solving one-step equations is to isolate the term. So let's take a look at this equation. We have f plus 9 equals 20. If we look at the f highlighted in yellow, that is what they're referring to when they say isolate the term. We want to isolate the term that includes the variable. In this case, it's the variable f. So now, what is my property of equality that I need? Who can remember from last week when we solved the one-step equations? Yes, Sarah. Correct. That is correct. Great job, Sarah. Our property of equality is subtraction. The subtraction property of equality rule is what we need to apply. Once we apply our subtraction property of equality rule, reminder class, the first line always falls. So on our left side, f plus 9 falls to my second line, and right behind it, we apply our subtraction property of equality. I put minus 9 on the left, bring down my equal, my 20 falls, and minus 9 also goes on the right side. For property of equality, we have to do the exact same inverse process on both sides of the equation to keep the equation equal. Once we apply our subtraction property of equality rules, our plus 9 and our minus 9 on the left side cancels, and then 20 minus 9, so leaving us with f on the left side, and then 20 minus 9 is equal to 11, and now we have solved our one-step equation where f is equal to 11. All right, thumbs up or thumbs down for those who remember that and got it right. Great job, class. So look at the goal. The goal is to isolate the term, okay? And we'll talk about that a little bit more in a minute. Now our vocabulary for our solving two-step equations will be isolate the variable, multiplication property of equality, and division property of equality. In our bell ringer we had this morning, everyone should have gotten the equation 2x minus 32.50 equals 212.50. Thumbs up, thumbs down for those who got it correct or not. Thumbs up, thumbs down. All right, very good, class. You remember what we learned from yesterday. Very good. That was our lesson yesterday, interpreting the real-world problem to create a two-step equation. Now, we are going to focus on that first term, 2x, that is in orange. We're going to focus on that. This is the second step in solving our two-step equation. Because we have a coefficient attached to our x other than 1, it means we have to do one more step in order to isolate my variable. And that is our vocabulary, if you notice. Okay, so who can tell me what is the operation for 2x? What does 2x mean? What operation is that? Yes, Lindsay. Very good. That is correct. 2x means multiplication. So when I look at my term 2x and I know it means multiplication, then what property of equality is needed to isolate the variable? Hands, hands, hands. Yes, Ernest. That is correct. You have to apply the division property of equality to isolate the variable. And that is our second step. So now we're going to look at a problem and walk through the steps of solving our two-step equations. The first goal, notice the first goal is isolate the term. Notice that that was also the goal of our one-step equation. So we're going to do the exact same thing we did in solving a one-step equation. That is now our first step in solving the two-step equation. So let's start with this equation. 2x minus 3 equals 15. The goal is what? Yes, class, isolate the term. So in order to isolate my term, what property of equality rule do I need to apply to this equation? Yes, Juby. That is correct. We need to apply the addition property of equality. Now, I wrote the original, the first line again so that we can line our steps up. So we have 2x minus 3 equals 15 on the first line. So now on the second line, 2x minus 3 falls from the first line. And now we're going to apply our addition property of equality rule. Plus 3, line up my equals. The 15 falls. And right behind the 15, I also say plus 3. That completes the second line of our equation in applying the addition property of equality rule to isolate our term. Once we cancel our minus 3 and our plus 3, we're left with 2x on the left side, and then 15 plus 3, that equals 18. So equals falls, and then 18 falls on the right side. Now, does this look familiar? Now we're ready to discuss the second goal. Isolate the variable. We have 2x minus 18. So our last and second step is to isolate the variable. And what property of equality rule do we need to apply? Yes, Miles. That is correct. We need to apply the division property of equality because 2x means multiplication. You know what? You are so insightful, Lavina. That is correct. When we're looking and thinking about our property of equality rules, we can relate it to PEMDAS when it says multiplication, division, addition, subtraction. So the opposite of multiplication is division, and the opposite of division is multiplication. And then the opposite of addition is subtraction, and the opposite of subtraction is addition. So we can relate PEMDAS to our property of equality rules. That helps make sure that we apply the proper rule. So in applying the division property of equality, we're going to divide both sides by 2. Okay, once we divide both sides by 2, on the left side, my 2's cancel. And I'm left with x. And then 18 divided by 2 is equal to 9. Now I have just completed solving my two-step equation. All right, let me take the temperature of the room. Thumbs up or thumbs down, those who understand that second step in isolating a variable. Okay, very good, very good. We're going to do another one. And in this example, we're now going to combine what we learned yesterday and what we learned today. So, in our example, we have Nala and two friends spent $21 on movie tickets M and one box of popcorn that cost $6. How much did each movie ticket cost? Okay. Now that we read through the word problem, now we want to slowly go back to the first sentence and dissect each piece of information to make sure that we write the proper two-step equation. So it says Nala and two friends spent $21 on movie tickets. So if I stop there, what is my $21? Yes, Christian. That is correct. $21 is your total. So the total means that is your equal. So we can first write on our first line, just in developing our two-step equation, equals 21. Now, let's go back to the very first sentence again. It says Nala and two friends spent $21 on movie tickets M. So Nala and two friends, how many people is that, class? Okay, how many people is that? That is correct. That is 3 people that bought movie tickets. Therefore, our variable or our term is 3M. Now that we have that, we're going to look at the last part of that sentence that says they bought one box of popcorn that cost $6. So the $6 plus the movie tickets is equal to $21. So to complete our two-step equation from this word problem, we add plus 6 to the left. So the equation becomes 3M plus 6 equals 21. All right, who got that? Who got that? Very good, very good. Now, you guys are in teams, so discuss briefly with your team the property of equality rules that you're going to need to apply to this equation. Think about the first goal. First goal is isolate the term. Think of the second goal, isolate the variable. So I want you to look at this equation and talk together as a team to determine which operations you're going to need to use to solve this two-step equation. Okay, which team wants to give it a shot? All right, Team Jessica and Larry, what do you say? What properties of equality rules are you going to need to apply? Oh, good try, good try. You know, there's one rule that's not correct, but we're going to have another team help and assist so that you can see that you need to use the inverse, okay? So another team. Okay, Team Juby and Sarah, what do you say? That is correct. Very good. Good job. We have to first apply the subtraction property of equality rule, followed by the division property of equality rule, based off of our two goals. So, the first goal, again, is to isolate the term. So we're going to use the subtraction property of equality rule for our equation, 3M plus 6 equals 21. So again, that step, we're going to bring down our 3M plus 6, subtract 6 on the left, bring down our equal, bring down our 21, followed by minus 6 on the right-hand side. That completes our subtraction property of equality rule to isolate our term. So that means our plus 6 and our minus 6 cancels, leaving us on our third line when we simplify with 3M, line up our equals, and then 21 minus 6 is equal to 15. Now that we have it as 3M is equal to 15, that is our clue that we're heading into our second goal to isolate the variable. In isolating a variable, we are going to apply the division property of equality because 3M represents what operation? Yes, Johnny, that is correct. 3M represents multiplication. Therefore, we have to apply the division property of equality. Once we divide both sides by 3, and we cancel our 3's on the left, we are now left with M on the left-hand side, and then 15 divided by 3 is equal to 5. Now, this is a word problem, so it's not enough to just say M is equal to 5. We must answer the question. They want to know how much does each ticket cost, so your final solution is to write each ticket costs $5. We have to answer the question. Great job, class. Now, I want you to now get in groups of 4, and it's your turn to try it. Our problem we're going to do together, you're going to do as a group, is Andrew rents bowling shoes for $4. He bowls 2 games. Andrew spent a total of $22. How much was the cost of each game be? All right, group. Get in your groups. I'll walk around and see how you're doing. Thank you.